Okay, good morning, everyone. And I would like everyone once again to give a very warm welcome to Armin, especially as today is also his birthday. So happy birthday, Armin, and yeah.
Okay, good morning. So I like to give presentations about topics which are sort of recent. And the last year was basically me starting to work on Sentry. And as such, I took a few things, learned from there, combined with prior experiences. And this is sort of the talk about it, which is to iterate and ship. Normally, I do open source libraries, and now that I'm working for Sentry, I can sort of do open source as a main source of income, I guess, which is very nice because it has many of sort of the same ideas of how you develop code, just that it's an application and not a library. So if you have been here for the talk yesterday, there was a brief mention of what Sentry is, but it's basically an error tracking online service. So you sign up on the website, you get the user account, and then you can add a little agent or library or whatever you call it into your application. And whenever you encounter a crash or you see something else that's relevant, you can send the data to us, we aggregate it, and we group it up for you. So it kind of looks like this. You see, well, that's not a very good screenshot, unfortunately, but you can kind of see like it's a type error and why it happened. Then you can see what led up to sort of the recent failures. In this case, it's JavaScript. So you can see where the HTTP requests were made, some log messages when the URL changed from one page to another. And then obviously, you can have stack traces. Sort of that's the core of what Sentry is. And what's interesting about it is that Sentry is basically an open source product. And it's two products in one, basically, for us, at least internally. One of it is Sentry, which is sort of what everybody can install on their own. And the other one is what we call internally Get Sentry, which is sort of an additional code that's only relevant for us. For instance, it has the billing, the quota management, and so forth. And the reason why this is interesting is because Sentry in itself has a monthly release cycle. So every month there will be a new major release and features go out of in sort of this release planning process. And everybody can install this. So there is this hope from our side that when they download it, the tarball or get it on PyPI, that it actually works. And it is a reasonable feature state. So you can compare this. We ourselves release multiple times a day. So every couple of hours there will be a deploy, sometimes multiple deploys an hour. And you have these two basically, you have two different ideas of how software should go to a user. One of them is as quickly as possible, and the other one is in as stable manner as possible. Because what you don't want is have a half-baked feature go out with a release, and then it doesn't work for people. We can do that easily on Get Sentry, because if something is wrong, we just ship out a patch to fix it. So this is basically my attempt to show you how we're doing this and why it can also be relevant for people that don't actually have two release cycles. Because I think, first of all, for some people, the idea of having a software as a service platform and then also the ability to install it on premises for customers is quite a nice thing to have. And for us, it came sort of automatically because we started with an on-the-premises solution. But it is a very nice feature to have because you can go to customers and tell them they can actually use this, even though they would not be allowed to use a software as a service application because of regulatory requirements or something like this. So the goals for us to work on Sentry is we want to deploy as quickly as possible. And we want it to be as impossible as possible for people to screw this up. And if for whatever reason a bad deploy goes out, we want to be able to go back as quickly as possible. So this deploy in seconds is a little bit of an unachievable goal because from the moment we check code in to actually it appearing live, it takes about 15 to 20 minutes. It's very hard to make this fast at the moment because of some of the safeguards we have in place. And this has to do with the fact that we don't want people to accidentally push out a build that breaks everything. So you can't deploy without it first going to integration testing. The rollbacks are much faster because we already know the old state of the software. We keep it stashed away. So falling back over to an older version is much easier. And then in addition, we have the goal that we want to tag a release off once a month. And I understand that that is probably something that is very unique to us and not something that a lot of people are sort of familiar with as a concept, that you have both of those at once. But I think it's a very interesting problem to have to unify those two different flows. So our general workflow for checking in code is you commit something, someone else is going to review it. It will then be integrated into master and then deployed. A lot of those steps are at least partially automated. Obviously not the deployment, the code commit and review process, that's always humans. But integration testing, that sort of kicks off automatically. You don't have to do anything for that. I think most people are familiar with this concept. Deployments are sort of semi-automated, and we want to sort of improve this going forward. But all of this really only works if you have a few upfront setups in your code. The biggest one is there needs to be a really good test coverage. If you make it very, very easy for people to deploy and there is not a good test coverage, it sets up this emotional barrier that you can really easily screw up. And that's not a good situation to be in, because it makes it hard even for experienced programmers. But if you bring someone new on the team and you tell them this is the button and it instantly goes live, it's a really hard thing from an emotional point of view. The other thing is that I think a lot of companies notice is that your production environment will always be a little bit different than what developers have on their own machine. And it's obviously a possibility to take the entire production setup and put it into virtual machines onto people's development environments. But it's also usually something that takes a lot longer to iterate on, and we don't want to do that. So our local setup for development is not entirely the production setup, but it tries to approximate as good as possible, and it's very easy to get started on it. This is obviously partially because we were an open source project as before we were a business, and as such, it's important that people can contribute to it. So there was always an emphasis on how to get running on it. But at the previous company I worked for, we had sort of the same internal goal, is make it as quickly as possible for people to get started developing code, and try to deviate as little as possible to the production environment. And as mentioned, this makes it much easier for new people to get started on the project. And for just committing code, since tests and everything of that sort takes a little bit of time, we also run code on people's computers before they actually commit something. So for instance, if you have a proper setup for Sentry development locally on your computer and you do a commit, we run a bunch of sanity linters before a commit goes up. This is a very good way to make sure that we don't, at least overall, don't degrade in code quality. I mean, obviously it doesn't catch a lot of things, or at least it would be nice if we would catch more of them. But it also catches a bunch of really annoying bugs. For instance, someone forgot to import something, or an additional import appeared because of a merge conflict, something like this. This is very, very useful, and I'm surprised that not more people use local GitHub hooks to make sure that their commits are at least reasonably sorted out. Our release schedule is basically on-premise goes out once a month, and our hosted deployment has multiple times a day. And this means that we want to keep master as stable as possible. So this is the pulls from the main GitHub repository, and you can kind of see that there are 104 merge pull requests. And this is not other people contributing. It is primarily us making pull requests against our own repository. So that is actually sort of a new rule, but we don't do commits against master anymore, except for changelog entries and things of that sort. We tried, I'm actually quite curious, how many here are actually using GitHub for primary code development? I would say that's, well, it's not half the audience, but it's at least a third, I guess. So this is the first time I'm using GitHub as a deployment, as a code development, I don't know, central point in a company and not as an open source project. And I find it very hard sometimes to deal with how they want you to develop on it. in particular, code reviews are not super nice, and branch protections didn't actually work for us. So we wanted to have this thing where you can only enable this GitHub branch protection, where you can't commit to master at all. That turns out to be a horrible idea, at least until you can customize what would be a permitted push or not. It didn't work for us. In particular, we have so many pull requests going on at the same time, and we also want to have these change logs going into this changes file. Usually it means that someone had the changelog entry on the pull request, so when you merge it, it just becomes a merge conflict, so you have to go back and fix that up, wait for the tests to pass again, then merge it into master, because you can't merge into master otherwise. You also can't squash merge into master with GitHub branch protection, which is hilariously enough even breaks the on pull request merge a squash button. So I don't think that feature is used by many people, and it didn't work for us. But it would be very nice as a conceptual idea to say you can't actually push to master at all. So everything goes into pull request, and then these are merged after a small code review into master. So basically master is stable. But that doesn't necessarily mean that master at any point in time is a reasonable development sort of release point. And part of this is because imagine you have a big feature, and that feature is 6 months of development time. One thing we don't want to do is have this huge feature on a pull request standing for 6 months. One reason for that is that it's very hard for people to review it, because they have to check it out locally, and if it's hard to review, then nobody does it. And they kind of cheat then, because they do the code review by just reading the diffs. And nobody, and as the diffs gets larger and larger, people just look at some of those things and see if they're like obvious ones, like things that the linter would have caught anyways. So because of that, what we do is we merge features in very quickly. Even if it's a 6 months feature, we break it up into smaller tasks, and they go into master regularly, which means that as a release goes out, there are partial features in there. And I will show a little bit later how we deal with this problem of code being in a release that's completely irrelevant for the release. So basically, we branch off master, we make a pull request, and we merge. There is no exception to this rule on the main Sentry repository anymore, but because this is, at this point, a surprisingly big project, this rule is not yet enforced on all the components that go into it. So for instance, we have the clients. So these are the little agents that you can install in your different programming languages. They, for the most part, don't follow a pull request development model or code review-based development model, largely because there are not enough developers on each client yet. So it doesn't actually gain us anything to say like there has to be code review, because it's very likely that the only other person that can do code review is either not there or doesn't have enough experience with this code anyways. But to compensate for this, we make very rapid releases on the clients. So the Python client, every release has a changelog of maximum 3 items. So the releases for the Python client go out almost every week, something like this. And then if there's temporary breakage in it, we just fix it up. So pull request-wise, it's kind of annoying on GitHub. The best thing we have found is you write your code as normally. You send a pull request. There's a command line utility called hub, which makes it a little bit nicer. And then we use the GitHub team mentioning feature to like notify different teams. So for instance, if this pull request goes to the UI team, then you do @get sentry/UI, and they get at least a notification. It's not ideal. I wish this would work much better on GitHub, but it's at least something. And the other thing we do from some of the repositories, pull requests notify into the main Slack channel. So people will just naturally look over this. To give you an idea how many people are, we think we started a lot of this process when we were 5 people, now we are 15. So we're really small, but the idea is that we scale into smaller teams if we have to, so that we can keep the same model within the things we're doing. So maybe we will have eventually more people on the Python client, the Python agent, so that we could sort of separate this out without having to change the development model. But obviously, it doesn't always work. Eventually, there will maybe be too many developers on the main software component, and then this model of notifying everyone in a Slack channel will probably be just annoying. For the moment, it works. The other thing is that when you release multiple times a day, you have to develop your code differently, at least if you want to avoid customers getting annoyed by you doing code deploys. And the biggest one is avoiding downtime. And I think that is tricky because very often you just can't fully avoid downtime, and it just turns into slow time, which is sort of the same thing as downtime. And slow time obviously means that things sit in a queue somewhere waiting for the deploy to finish so that they can pick up again afterwards. Avoiding downtime is very tricky, and it requires you to make some sacrifices on how you develop a code. And some things also can help you. One of the biggest helpers for us is Postgres. This is sort of our database of choice. And very often it's very easy to complain about the database, but then at the same time, when you then compare it to other things that you could use, Postgres is actually really good for us. We had some issues with it where we have so many writes going into Postgres that we're sort of the worst case, I guess, model for what goes into Postgres. So you have to imagine we have people sending in lots and lots of events that go into Postgres, and then after 90 days, we kind of want to prune them out. So we have lots of writes, we have lots of deletes, and then Postgres is MVCC, MMVC, what's it called? No, it's something else entirely. This concurrent data model where when a transaction starts, it sees a snapshot of the database. So one of the things they do internally to implement this is they have this transaction counter. And this transaction counter can go up to, I think, 32 bits. It might even be signed, I'm not entirely sure right now. But when it overflows, your data is corrupted. So in order to prevent this from overflowing, there's a safe spot earlier where it will just stop accepting any more writes or anything at all. I think reads, I don't even know if reads are possible. But if you hit this magic point, then you're screwed, because now you have to run a full vacuum. And on our data set, that takes a day. So we don't want to hit this point, and it's very hard sometimes to not hit this point. It took us a lot of tweaking of the Postgres setup to make it transparent and do it in the background. But that's sort of our big complaint with Postgres, is that it might not be the right setup for what we do. But there are so many things that does really well. One of them is transactional data definition language, which means that any of the modifications you do through migrations on the schema, they're actually transactional. So if something goes wrong, you can back out of it. That is huge. And I've used MySQL a couple of years ago, and I used MySQL originally, then I used Postgres, and I used MySQL again. And that is the first thing I missed going back to MySQL, because it's not very uncommon that a migration works locally, and then all of a sudden it breaks on production because of some reason, and you end up with this really weird state where stuff hangs around. You're not quite sure, was it supposed to be there, was it not supposed to be there, so you have to manually go in and try to clean it up. And then also your code has to work with this partial data sitting somewhere. That is not a problem if you have transactional DDL. The other thing is we can build indexes concurrently in the background without having to lock anything. That is really good, because we have such huge tables that building an index would otherwise take days. And this way, it does take days, but it does it in the background. And the fact that we can actually alter tables without having to take down anything and do this magic things where we rename tables, build a copy, and then try to merge data over, as you do with MySQL, for instance, is absolutely not a problem with Postgres. So for us being able to deploy quickly, and even with big schema changes, Postgres is right now very hard to replace. I used MongoDB previously, and one of the reasons why I want to use MongoDB was that it's actually quite nice, the idea at least conceptually, that your code looks at the object and then tries to figure out from the object if it was the old version or the new version, and sort of you do this data migration on the fly, and schema doesn't exist at all. But eventually you end up with this case in your code where you have to deal with all the old versions that ever existed for any object at all. So unless you then go in and manually rewrite it, you end up in the same situation as you would do with a schema-based database anyways. So actually, I think that this schema is very nice, and I would not want to throw it away given the alternatives. The biggest worry with doing many code deploys, I think, is bidirectional compatibility. If you have one release a month, it's very easy to test that the old version and the new version work together, and you never have to roll back. At least theoretically, you can do that. If you deploy every couple of hours, it happens every once in a while that you have to fall back. And then you have this issue that the database data and your code data might not completely work together unless you take some precautions for this. The other one is that it can absolutely happen that not everything on the entire cluster of machines that you're running actually runs the same version. So a very common problem is you have some new code pushing a task on a queue, and the queue worker runs old code, and the data that they're working with potentially doesn't work together. So that's why we take quite a bit care to make sure that the data that is being accepted at any communication point or anything of that sort is compatible upwards and downwards for a couple of days, or even longer if necessary. That requires a little bit of upfront planning. Particularly data migrations are a big deal with this, but it's manageable. And if you do it every couple of hours, you will get used to this idea anyways. And you don't miss it as much anymore. When I did sort of this on-premises service software before, it's very easy to just forget how much of an impact migrations leave. And then at the end of the month, you have this huge data migration to go through. And then it kind of just blocks out the entire cluster, and there's no clear way to go back. So that is nice, because by doing it every hour or every couple of hours, you're exposed to the problem and you start thinking about it properly. The other thing is that as you do code deploys, with the increased frequency of deploys, there's the increased frequency of users getting new code. And you want this impact for the user to be as little as possible. And that is tricky, in particular if you have long-running things. So Sentry doesn't have WebSockets at the moment, which makes it easier. But I had this problem with my previous company where we wanted to have quick deploys, fast deploys, deploys that don't show up to the user. And then you have this problem that there are database connection, WebSocket connections to the user code. One obvious thing is the deploy goes out, you close all the WebSocket connections, you load new codes, and you let the users connect back to the WebSocket. That turns out to be problematic for many reasons. One of them is that all the users disconnect at the same time, so when they come back, they put a huge load on you. So that's something that you can stagger out, where you only disconnect some machines at a time, and then some users come back. Then, oddly enough, you end up with this problem that as you increase the number of machines, users connect back to an old machine, even though they were on old code. So imagine this: there's a server with 1,000 WebSocket connections. All of them disconnect. The users automatically reconnect, because that's what the browser is instructed to do, and it comes back to server 2, which also still runs old code. And then you do the deploy there, and the user disconnects again. So you end up with this really stupid cycle of closing data WebSocket connections for absolutely no reason at all. So what I did at the previous company, and that's sort of also the plan I would like to do in Sentry, is the WebSocket connections are completely independent of your code. And ideally, whatever terminates the WebSocket connections doesn't at all have anything to do with the code you're deploying. So in the previous company I worked, we had what we called the concentrator, which was a central point where all the WebSocket connections come in. And these WebSocket connections accepted requests on the WebSocket or send out responses on the WebSocket. And what they did afterwards is they took this communication event on and put it on a Redis queue. And then workers, just regular Python code, picked up on these little instructions on the Redis queue and exchanged code this way. This meant that when we did the code deploy, we only had to restart the workers, and everything was buffered on the Redis queue. And only if there was a bug in the concentrator did we have to do an update on the concentrator. So that's why I'm saying the separation of the state, which is sort of the WebSocket connection, to where the work is being done. Actually, that's incorrect. So our workers are stateless. That's the whole point. That sentence doesn't really make that much sense, because the connections are what hold the states. So the state sits on the connections, and then the workers themselves are sort of stateless. They pick up little tasks and operate on those. Sentry has a similar problem where the event comes in for a new crash report that happened. It has to go into a queue, and then the queue has to work on it a worker picks it up on the queue. So we don't do it when the request comes in. We just, at the moment the request comes in, we just put it on different storage systems, particularly the queue, and then the worker picks it up. And between the front end and the queue, there can be obviously code differences, and we don't have to restart them at the same time. So it's a similar problem, but because we restart everything anyways, the only thing we have to be concerned with is that they mismatch version-wise. Another problem that comes up more and more often now for us is that we used to have a front end which was written in HTML. And one of the really trivial things with HTML is that the version that is being presented to the user 100% is in sync with the state of the worker that happened to be running at the time the front end was delivered. So in particular, a request comes in, for instance, log the user in or something like this, or show event view. And then the server runs a certain version of the code, and it delivers the appropriate HTML for that version. If you have JavaScript applications, what happens is that they don't reload anymore. So our UI is in JavaScript now, so the UI loads up, it runs there. But then we do 2 or 3 code deploys, and people keep the tab open for like 2 days. So the version of the application that they are running in their tab can already be severely desynchronized with what the backend has. So this is actually a really confusing problem when you have it, because you get errors that, like, we fixed this 2 days ago, but actually the user still just went to sleep with his laptop and came back, and he's still running the old version. It's becoming more and more of a problem for us because we are rolling out, we're basically deleting all the old HTML code that still exists. So right now, sometimes if you click on a certain button, the web page has to reload. But as that goes away, we will eventually have to deal with forcing people to get a little update prompt, like reload your page now, or just automatically do it in the background. So detect that the version of the UI loaded is different from the version that the server expects. And then instead of just doing the React navigation, what we're using, we would just fully reload the page automatically. That's an interesting problem to have with JavaScript, and I think it will be more and more common for users. So for us to be able to push deploys up really quickly, we need to make sure that the tests run. For us, we have, as mentioned before, sort of 2 products. One of it is Sentry, which is running on Travis CI, the open source version, which tests all the code. I am assuming everybody here is using Travis, and if not, you really should, because it's sort of underpinning modern open source development on GitHub at least. And we have so many projects on Sentry that at this point, I think we are paying them for the open source version as well. Because they have the open source version of Travis and the closed source version, and we sort of stress both of them. So the open source version of Travis tests all of our open source code, but we treat this separately from the deployment we're doing. So if you're doing a change on Sentry itself, it's going to the open source repository, but the deployment goes out of the other repository, which sort of gets Sentry. And this one is tested on no, it's actually tested on Travis CI, but it's tested on the closed source version of it. And this only tests the code that is relevant for us. So one of the effects of this is that the get Sentry test code actually also runs the Sentry test suite in a reduced form. So when we push a broken, let's say we make a new bug fix for something, and it breaks MySQL on the open source test, then we're okay with it because we don't test for MySQL on our production builds. So we treat this as 2 separate problems. And this also means that the tests are a little bit faster for deploys. But the tests take a really longer time than I want to run, and we require the tests to pass before we can do a deploy. So part of the reason why our deploys take 15 to 20 minutes is because we'll wait a really long time for Travis to finish. So as the build goes into Travis, we use we have built our own system. It's also open source. You can use it if you want. It's kind of undocumented. It's called Freight. Basically, the way we do this is Freight waits for Travis to pass the build, then it builds it. So pass the tests, then builds it, and then ships it off. One thing of note here is obviously on Travis, we have a separate build from the one that we are building for deployment. That's not ideal, and we would like to fix that. But it's good enough, and a good enough solution is actually sometimes better than the alternative. Because this also sometimes means that if Travis, for whatever reason, is not functional, we can disable the check, and the build process independently can still function. This is sort of what it looks like. There's a web interface where you can see the deployments that are going out at the moment or went out previously. And the other thing that we're doing is we have it hooked up with Fubot. So you can write it in its Slack channel, please deploy this now, and you also get the notifications if a deploy went through, if it was canceled, and so forth. That's, I think, one of the best things is getting the build messages into your communication channel, because it immediately gives people awareness of what's happening on the server, or why deploys wouldn't go through, and so forth. So I think we still might run this on Heroku. At least you can easily deploy this yourself on Heroku. It's sort of a clone of a software we used before. I think we might have used Heaven or God. I'm not entirely sure. That was before I joined Sentry. But in this form, it's really nice because it gives you insight on what's happening, and it decouples the deployment process from something people wouldn't be aware of. Everybody can write who would deploy docs or who would deploy Sentry. And it just picks up the correct configuration from master and pushes up. Problem, obviously, I mentioned this before, the dev setup never really matches prod, so you have to make sure that rollbacks work, because just because something passed on a test suite or passed locally doesn't necessarily mean that it is also functioning correctly on live. So for us, fast rollbacks are really important. We want to be able to go back to an earlier version as quickly as possible. And we also do this through Freight. And this is also why backwards and forwards compatibility is really important, because you might already have done the data migration and now you have the old code running again. Sometimes you can't always support this, but most of the time it's a really important thing for us. In regards to code structure to support of frequent deploys, one of them is you notice that large systems turn into organisms that are really hard to understand. This is thankfully less of an issue for Sentry, but I had this at a previous company where on production we pushed so much stuff through our queues, and in development we never really did, or on staging we never really had enough load on the system to sort of encounter some of the oddities that would happen as a result of this massive queue usage. And it's hilarious what happens. Like we had a game launch where we had a 110-second oscillation on all of our request graphs, and it didn't make any sense why that would happen. Or we had this issue where if you would push it even slightly past the breaking point, the system would like overload and would not accept requests for 2 minutes. And it was impossible to understand from an isolated point of view why it would do this. And this is something that as you scale up systems to a larger scale and you introduce more components and more servers, it's for a normal human being almost impossible to understand why certain things work in certain ways. So you have to at least be conceptually aware that things will happen in production that don't really make any sense on first view. The most obvious case I already mentioned, not everything runs the same code all the time. That's a big deal. That causes a lot of really funny bugs that come up. Sometimes it just happens because the deploy is slow. In the past, we had the problem that the builds that went to the servers were built on the server. So there were slight disagreements in regards to how static files went up. So some versions might have slightly different forms of the static file running, like JavaScript, for instance. Sometimes we used to reuse virtual envs in Python. So one of the most hilarious things is when pip installs slightly different version of the same library on different servers because it just decided that it's good enough for the version pin. Also very frustrating because it becomes impossible to understand why in isolation you can't see the problem, but clearly it happens in production. So that is very, very annoying. And we're now dealing with this with having one build that goes to all the machines. But still you have, through the slowness of the deployment, this possibility. Data schema has roughly to be synchronized up with code behavior. That's just a nature of deploying frequently. But that is something you can deal with. It just adds a little bit of mental overhead. And so this is our biggest sort of tricky part on doing development with frequent release cycles. That's the idea of we want to still do really large features, but we still want to be able to use our very fast deployment setup. And the way we're doing this is we have this big feature we want to do. We try to at least conceptually break it up into smaller features. And then we just push those features live as quickly as possible. Which means that, for instance, on-premises Sentry customers, they are running an upcoming feature which will only be relevant in 3 months already for the last 6 months. But it's completely hidden in the UI. And the reason for this is that until the feature is ready for consumption, it's flagged away. So unless you flip very sneaky configuration variable, you will not see this. And yeah, we shipped some code to sort of on-premises customers, which in a future update would just be backed out because it turned out that feature wouldn't work in this particular form. This is also kind of interesting because you can sign up for an early adopter on the version of Sentry that we host. And in that case, you will sometimes see some of those features which we deem interesting enough to already be used by people. And also for us, we run with all feature flags enabled. So we ourselves, when we use Sentry ourselves, which is kind of nice that we can do that, we would just see all the features as they come in, even if they're partially broken and so forth. That in itself also has led to some problems. We had a semi-broken UI for 8 hours because we didn't notice, because it was fixed in the feature version, but it was broken in the non-feature version. So that's the problematic case with these feature things, that you sometimes don't quite see the same version that some other customers see. But I think overall, it's a very good thing, especially because when the feature system is implemented, you can do some more crazy changes and then try to test drive it with customers. And when we rewrote our user interface from just standard HTML to a React UI, we were kind of scared internally because there was a 1.5-year rewrite, basically, I think it took in total. And if you present users with a completely new UI from one moment to the other, you will get very angry faces, even if the UI is better. So we actually ran both systems in parallel for, I think, a period of 6 months, and we just iterated on it. People had the option to switch between the two versions. And part of that was enabled by our general way of dealing with this idea of these feature flags. That at least makes it easier for customers to understand that their user interface is changing completely, is if they have the option to test drive it a little bit earlier. So we don't have an easy way to opt in, I think, yet, or maybe we already deployed this, but you can say, like, I want to be an early adopter or not, and you can see the version that will come out soonish, and the version that actually runs right now. Yeah, so last part is basically we want to reduce the total number of moving parts we have to make it as straightforward as possible to develop on it. Biggest one is we don't want to compromise on the things we are running in production, but at the same time, we don't want to have dev a completely different experience. So in particular, we used to run with the queue disabled in dev. I think most people now run with the queue enabled on dev because having the queue and not having the queue is just such a vastly different experience. It was just too easy to break things in there. I personally absolutely believe that virtual machines are not supposed to be used for local development, even with Docker. I know that there are some disagreements on this. Docker makes it much easier, and maybe we will get to the point where everybody can run a local VM. But I personally want people to enjoy working on the code base, and Docker adds another layer of confusion and interaction into it. Particularly for a long time period, file system notifications were broken, and there still are if you use the release version on Mac and not the beta version, where it just gets frustrating. Sharing files in and out of the virtual machine is not ideal. Just having to deal with 2 operating systems at the same time is not as much fun as just having one. So we try to keep this in mind and support people on having a local development environment that does not require the use of virtual machines. Reproducible builds are huge. I can't tell you how many times our deployment broke from one moment to the other without anyone doing a change, just because a dependency of a dependency of a dependency decided to update. So we freeze and shrink wrap everything. I ranted on Twitter a couple of months ago about the absurdity of the Node ecosystem with having one-liner dependencies. Personally, it frustrates me so much because the amount of mental overhead we have to deal with because of this dependency madness is a little bit unexpected for a Python developer. I guess when you get used to this idea that there are so many damn dependencies that it gets a little bit easier, but we had just so many breakages. And it's just because Node dependencies also deploy more frequent than you expect, you can end up with a situation where if the builds are not completely, basically you have internal dependencies on libraries and that you set yourself. But those dependencies have dependencies on other things. And these dependencies usually, in Node at least, for a long period of time were not equal dependencies, but they were like semver dependencies. And which means that within whatever is considered a reasonable upgrade, those dependencies can upgrade, but don't have to. Which meant that when we reused build environments, some versions of the application would run an older version of that dependency of a dependency, and some of them would run a newer version of the dependency, and it gets confusing. Also, it just becomes way too hard to comprehend. So shrink wrap it is, everything runs exactly the same version, and also we only make one build now, and it goes to all machines. For us, obviously, since we are building a development tool that solves this problem in particular, which is to monitor failures and figure out why they happen. One of the things we do is we associate failures with users. Sentry does this automatically. And then as users go to support requests and say like, stuff broke, help me, I can see why it broke. And in case of Sentry, because open source, it's actually really nice because we can link users to the bug report into our own internal repository. So sometimes you have a user that has a support request. We already know about the breakage anyways. So we link the user to the new GitHub issue, and he can track the progress of his failure on the support request on the GitHub issue tracker. So yeah, you could use Sentry for this. We also built a bunch of little friendly robots to help us with all these things we're doing. We like to replace ourselves as much as possible. One of them is we have a bot that commits to repositories certain things. For instance, because we have Sentry and get Sentry, we want to update the pins depending on certain conditions. So whenever you contribute to Sentry, it will also the bot will go in and make an update commit to get Sentry, as an example. We do this the same for our docs, which are split into many, many different repositories. We use this to update the submodules. We integrate with GitHub to make sure that our build failures from Travis, Travis integrates with GitHub, we don't have to do that, but you can see the build failures on GitHub. We try to push as much as possible into this GitHub interface. And then we just notify into the main communication channel as much as makes sense, particularly from the deployments. End result, I think, is we have a better climate, and that doesn't necessarily mean company culture or something, but in this case it just means because we have so much automation and so much test coverage and all of this sort of runs automatically, the fear of doing damage when you come into the team is much smaller. And I think it's a very nice thing when you come into the office first day and you can get your feature out and it shows up for the world to see, and you don't have to be afraid of doing that. And for us, because we're an open source project, it's very nice to see people respond to that. So the fact that we have so low iteration times, people point it out on Twitter. And when that happens, it's just really, really nice. And it's something that's rewarding and not frustrating, and gets you over this this thought of there was a value for doing it, which is not just to satisfy yourself, but also to satisfy customers. Yeah, that's pretty much it. If you have any questions, just go ahead, and I'm happy to answer. It doesn't just have to do with Sentry, it can also go to other topics.
Hello, thank you. Could you say something about infrastructure and how you handle changes in infrastructure and that kind of thing, if
like
you have it all in code? Sorry?
Like adding machines?
Yeah, or like how the machines are provisioned and whether you version control that. And
so I think most companies end up with the infrastructure ideas that the first person who put the infrastructure in place had. In this case, it was David Kramer, and David Kramer he really likes bare metal. So pretty much everything that we have, with the exception of some AWS services, runs in soft layers data centers. So provision is different from what I'm used to. I used to do AWS for the most part. So I used a combination of Bodo and other things. Especially in the end, I ended up using more and more Ansible because you could automate AWS for Ansible quite well. That gives you instant everything. With software, it's a little bit different. You bid on the servers. So if you want to have another server, there's talking to a person, basically. And then it takes a couple of hours for the server to appear, and you have it, I think, for a minimum of a month. So that's sort of a different way to deal with it. Also, we use Chef for pretty much all of the provisioning, also because David Kramer likes it. I don't mind Chef, but it's very weird in many ways, and it wouldn't be my first choice, I would say. And I think Chef got us very, very far, and we're very happy to have it. But I definitely would not pick it again. My personal favorite for a long time was Salt for server provisioning. I think it's a little bit, it can be a little bit hard to figure out what it's doing sometimes. Ansible does it a little bit better, but Ansible also takes really long time to do anything, which is sort of the downside of it. So you end up with this hackery to make Ansible slightly faster. Yeah, I think that's as far as provisioning of the servers go. Some of the services that we're using, I don't actually know. I think for the most part, this is sort of how we do it. We started using Docker to do a lot of things recently with different levels of success, I would say. It's a very cool concept. I would like it to work as good as advertised. It just doesn't. In particular, one of the problems that we have constantly is the networking in Docker, and that's probably not even Docker's fault, that might be a Linux kernel, but the networking in Docker is very different than the networking is supposed to work. And by just putting Docker in compared to not having Docker, we saw random things happening that we didn't expect. And there's like one of our most common issues is connection reset that shows up in Sentry, because something in the way that the internal bridge network in Docker works does something on TCP connections, which it doesn't do otherwise. Also, just being able to look into an application is much easier without the container. So Docker has its upsides, its downsides. The upside is obviously we have the same thing running everywhere. And also the idea why we went for Docker is we want our on-premises builds eventually to be users just using the Docker images. Yeah, so I think that's it as far as our provisioning goes.
Hi, thanks for a great talk.
Can you show up your hand? I don't know where you are.
I'm here.
Yeah.
Yes, so you talked about having a front-end server and push events into Redis and then read from that. There's some work going on with Django and Django channels and ASGI. Do you have any comments on that, or do you think that's a good direction?
Yes to Django channels. I'm lukewarm on ASGI or whatever it's called. So the concept of like the Django channels is pretty much exactly what I did for a couple of years already. So I'm kind of familiar with what works, what doesn't work, and I like it a lot. You can also go to some of my, I did a bunch of presentations about this as a concept already a few years ago, and there are some blog posts about it. I really like it, and that's also why I talked to Andrew as he was doing it a little bit, and I had 2 or 3 email exchanges on this topic. So I like the concept a lot. I think it's the best concept in the world, to be honest, to do it this way. The only problem is that there is a breaking point, I would say, in as far as you can go with this concept. And that is basically you have to be, you lose some flexibility by pushing things through a queue, unless you want to have serialization, deserialization, serialization, deserialization everywhere. And it just makes everything slow and puts a lot of CPU load on different parts of the system. Also, you have to deal with queue back pressure. You have to deal with all kinds of shenanigans. And my personal experience with this is that it's really good for sending events through. It's even better for distributing work that might not necessarily be relevant for what the user wants. So for instance, say you have a request that takes 25 seconds because you have a really slow HTTP call. One of the options would be just push it on a queue and have a queue worker work on it. But with Django channels, you could just have this as part of your regular processing and just say, from this moment onwards, just send a response back, but keep working on it in the background. But you have to start realize what the cost is of doing it that way. And there are lots of little nuances to running a setup like this. If you want, we can have a conversation about this later on, because it's a topic very dear to my heart. But the problem is that I think Django is going to popularize the concept among people that don't want to deal with distributed systems, and as a result, it will get a lot of negative reputation. That's sort of my fear on it. In particular, ASGI will sort of push this even further, where they want to start putting regular request findings for the queue, which I think might be not the right way to do it.
Anyone else has a question?
Hey, thanks for the talk. That was really interesting. How do you run database migrations?
So one of the things that's funny is that was not my choice, but we run Python 2.7 and we run Django 1.6. So we run really old things. And it's very hard for us to upgrade. And one of the things we're stuck with is self. So we run pre-Django migration shenanigans. And we want to change that because we would really like to upgrade at least Django. So part of the answer is we run really old stuff. And we wouldn't have to do this if we wouldn't have to support on-premises customers. Because we don't know from which version to which version they're upgrading. So we want to support them through this seamless upgrade path. On production, on our own stuff, we could in theory already use something else. So that's because we deploy so often, we don't have to support like deploying from version 2. So that's sort of like part of the question is what would you use we yourself. The other thing is we run multiple Postgres clusters. I think at this point we run 2. So there is some partitioning going on of tables, which also sometimes means that a migration that sits in Sentry, the open source version, cannot apply to get Sentry, our own version. And this is okay because we don't support partitioned database setups for on-premises customers. That's sort of a problem you really only hopefully have at larger scale where you have like thousands of customers on your database. And because of that, sometimes we have migrations where someone has literally to go in and run some custom SQL code. It's not very beautiful, I agree. But it's also a very pragmatic solution that just emerged automatically, and we want to improve on this. The other thing is for migrations that our migration code is for not any good reasons supporting SQLite and MySQL 2. I would like to kill MySQL support, but people have it running traditionally, and it's very hard to migrate off it. So we have to write 2 migration paths sometimes. Sometimes like self does the right thing out of the box, and sometimes a migration adds an index, and you want to build it concurrently on Postgres, and Source can't do that. So, and also because concurrent index builds are actually sitting outside of a transaction, so you have to structure the migration differently to support this. So we have like a little bit of a messy setup there. It's not super messy, but it's messier than it should be. If I would choose it, I would not use Elf again. I would also not use Django migrations again. I would literally have SQL files somewhere and apply them. Just because I understand what they do, and then when you have to run them manually, you just copy paste something into a shell. Whereas right now, there is the possibility for the migration to branch off based on previous data, which is not isolated in SQL, so you can't even dump the SQL commands out and then run them manually. So whenever we have a more complex migration, someone has to manually go in and write this migration by hand anyways in SQL. So that's just waste of time. Would not do that probably. Maybe I would do, because right now I don't have to write SQL code all the time. So maybe if our setup would be write SQL files all the time, I was like, we should have used Django migrations. So I don't know, but right now the grass on just writing SQL code is definitely greener.
Thank you.
I have a question too. Hello, thank you. How do you measure test coverage?
How do we measure test coverage? So when I did the slides, I saw a pull request, and we have this thing which is called CodeConf, which runs automatically, I think, coverage.py or whatever it is. And I looked through some pull requests to see one where the coverage was really good, so that I can show like, oh, we have test coverage and stuff. But the problem is the numbers that come back from it are really bizarre. So for instance, a changelog file changes, and then your pull request never gets green because your test coverage dropped off by one line. That doesn't make any sense. Why is my changes file in there? So the answer to how we do test coverage measurement is really badly. And I asked in the channel yesterday if anyone actually uses this, and it turns out that nobody even looks at those numbers. So I don't know, it's definitely something that in the current form we are doing it is not correct. And would like to improve it. But truth be told, I don't know how. And we have definitely under-tested situations as well, as most people do, I think.
Yeah, it's time for the break now, and a good round of applause for Armin for another great talk.